This meeting is being recorded.
Excellent. So I'm recording this meeting. So this is Coffee Compiler Club minus Cliff because he got snowed on and lost cable and everything else. So I'll send this to him afterwards if he wants to post it. You guys know Cliff's spiel, so I'm not going to repeat it. All right. So today we have a special guest or a new Coffee Compiler Club member, Levo. Is that how you pronounce your name, Levo?
Yeah.
Who's been working on a new language, and he wanted to do a demo of that. So I'm going to let you introduce yourself, Levo, and tell us a bit about yourself and your background, and then tell us what you've been working on.
Well, I'm basically a no one and never worked on a popular project, never worked at a big company, no one would recognize my name. So I've been designing
It
the
says
language.
Levo on the screen, so everyone's going to recognize it now.
Yeah.
I've been designing a language since late 2009, so over a decade, but actually programming it is recent. I did a number of prototypes, I think I did like 5 prototypes at least. But my main compiler was I started like a couple of years ago, and that's what I'm going to be showing today.
What is the name of the language?
I'm just going to link the website.
So Bolin, B-O-L-I-N. So bolinlang.com. We'll put that in the notes.
Does anyone want to try running it? And I just remembered I should show off a script, but I don't remember the path to it.
All right. So I will pull it up in a browser here and share my browser. How's that? Does that work for everyone?
Yeah.
Sure. See, since I don't really use Zoom, I'm kind of clumsy with it, so it might be smoother.
Sure. So let's see. How do I do this? I say share screen. I'm going to say browser, right? What's the browser? You know, I have 400 windows open.
And can you eyeball for the member strength to
Firefox,
join?
here we go. Say again?
To eyeball for someone, if someone has
I don't do that. That's automatic.
Oh, okay.
People can just join. If you got the link, you're in. I haven't had a problem with people jumping on my meetings and showing porn like they did to poor Cliff. So you guys can see my screen, my browser anyway?
Yep.
Yeah. Well, you guys got the links, so if it's not readable, you can pull up in your browser.
Yep. So come back tomorrow for an update. Okay, is it tomorrow or is that tomorrow?
Right now you can, tomorrow is going to be like in a more official launch, but right now it's just like a release candidate.
Cool. So Levo, you can see my screen?
Yeah.
All right, so what am I doing for a demo?
Nothing right now. So basically, if you guys think I'm doing something that's like kind of dumb or very difficult or like impossible, just like tell me. So I have 3 technical goals for the compiler, but after a few prototypes, I realized that the one thing I want for my language is to be readable. Just because after dealing with a lot of people's code, readability seems to be like something I should prioritize.
Mm-hmm.
So the top 3 technical goals, like when I started, this is the 3 I had in mind, is it has to compile as fast as C, not optimized C, but like everyday kind of C. Okay, so that's the performance. I also prefer it to compile really quickly. Like I'm trying to hit a goal of 2 million lines per second. And I forgot what the third goal was, but I guess
so
those are
fast
the
to
main 2.
compile, fast performance, readable.
Oh, okay. Yes. Let me see. Does a 2 million seem right, automatic memory management. Like I hate doing malloc and free. not because I get it wrong. It's just annoying. Like it
So when
feels
you
like
say
that line
automatic, there's
noise.
a lot of different automatics. Are you talking GC or are you talking
So
something
no
special?
reference counting, no GC. It
All
just
right.
the compiler figures it out for you.
Okay. There you go, Alan. That's what you wanted to do, right?
Well, I mean, I mean, I guess, but I don't know if he's done it. I mean, I have I have my own plan for implementing memory management, and I don't know if he's
What's
implementing my plan or like a different plan.
Hey, Aaron.
so automatic memory management's 2 million lines per second and as fast as C. Do any of these sound unrealistic or just
Nope.
impossible to do?
Nope.
What are your current compile
Like it sounds
times?
difficult in this, like the automatic memory management sort of competes with 12 million lines of code or whatever. So I mean, there is
Yes.
like you have to work hard to get both of them in the same language. It's not
So
impossible.
all three of those people always like give me shit about. Like they say each of those things are impossible, let alone putting them together.
Mhm.
So yeah, do any of you want to try running the compiler?
How do you do that? You have to download something?
Yeah. So the second last link at the top is download.
Download. All right. I accept the end user license agreement. What am I signing away here?
Yeah, it's if you're not using the compiler and you're just running the demo, you probably don't have much to worry about.
I mean, is
It's
this
just this is just to prevent companies from running it, like because I kind of don't want like someone to fork the project because
I see.
I heard a lot of stories. Yeah.
All right, so I've downloaded the zip. I'm opening the
Oh
file.
right, are you on Linux? It only works on Linux and Mac.
I'm on Mac.
Okay, so maybe it will work.
It should be fine, maybe.
All right, so what would I do then? I'd go to a command line.
You know what? Maybe I should just try to demo it.
Sure. So let
That's
me stop sharing my screen then, and I'll let you share your screen. How's that?
Sure. It looks like I don't have my compiler in my path, so just give me a moment. See, usually I'm developing it, so I don't want a stable version of my path.
So while he's setting up, I'm curious what happened today. Where's Cliff?
So Cliff is in his winter wonderland. He got a pile of snow apparently and lost his cable.
Aha. I guess those flat Starlink satellite dishes pointing straight up are great for collecting snow as well.
Does anyone here have Starlink?
nope.
No, but one of the guys I work with has it, and he also lives up in the California hills. I was surprised he had to cut off the top of one of his giant redwoods in his yard so that he could see the satellite. I wouldn't. I personally not sure if I would be prioritize my internet that high, but
He could have climbed up to the top of it and put the dish up there.
those things are so high; they're like 400 feet high or something.
Have you ever worked on one of those towers? They're
No,
made out of these like 4-foot sections of steel. They're triangles. So
like those
basically,
radio towers that stick up in the prairies and stuff.
So, and they're only about 8 inches wide, right? So you put one on, then you climb onto it, then you put the next one on, then you climb onto it. It's like they're the least stable things. And it's like, yeah, I'm not going to do this.
If you want to see something even creepier than that, I found a video of some steeplejack in England. these videos are from, he was pretty old, and the video was done in the maybe early 2000s. I don't think many people do this anymore, but he basically was going up the side of like industrial smokestacks and stuff, and raising his own ladders with wooden ladders and rope as he went. Like crazy. And sometimes he was going past vertical. It's like his ladder is actually like angled outward from the wall. You know, if there's like features that he has to go over. Madness.
So Levo is
I
writing
don't know
things
why I'm
ready to
talking
go.
about this.
Okay.
You
Yeah,
can
Levo,
share.
Levo, you gotta get some. You gotta interrupt occasionally.
Right. So could you guys see my screen?
Yeah. Let's see.
Okay. I don't see like a way to know if I'm sharing my screen. So
Well,
you
what
guys
we
definitely see
see
it.
is,
There's
yeah,
like
what
a
we see is
little thing
ourselves.
in the top
Okay,
middle, and
great.
that's like
Oh,
it's
there
like
we go.
orange. If you can see it.
So
Like-
earlier I said I want to compile 2 million lines per second. And I'll just show, this is just like a generated file. It's like whatever, like who cares? It's just I use this to test how fast it goes. So yeah, when you're on camera, typing is much slower. Yeah, I think I got the command right. So this is how fast I'm compiling at the moment, and you know, 4 seconds is pretty good. But after I write TCC, it's actually 1 second. It's probably slower right now because the desktop is being recorded, but I compile 2 million lines per second. I mean, yeah, 2 million lines in 1 second.
That's cool.
Yeah.
I mean,
I'm
I think
gonna
that's
do
what
something
people-
else here. So
Right.
you see how I just increased the array size?
Mhm.
If I rewrite in the command, you see that it actually does array checks at compile time. And this isn't just like known sizes. Dynamically sized arrays and growing arrays are both like I have 3 different array types. All 3 it checks the array bounds. Yeah, so that's what 1 million. I mean, 2 million lines per second with bounds checking and automatic memory management. So I'm just going to pull up my website. Actually, I should show this. So another thing I did was I messed around with the pretty printer. And if you look at the code, you can see that this is just basically an enum. But I call it a bit flag just because, like, you know, enums is just like serial, like 0, 1, 2, 3, 4. Everyone has a need for bit flags, or at least in my experience, bit flags are very useful. So I set up a pretty printer so it actually shows the flags instead of like a value. I also like set up arrays. So I'm going to rerun this at a different point. So you can see like it's fully debuggable.
Can you give us a tour of a main concept? I see classes, I see bit flags, which are enums. So
Yeah.
what kind of concepts your language implements? Does it have inheritance?
I'm planning to support inheriting an interface. So you can like just implement something with the virtual functions. I do not plan on like class inheritance and like overloading another virtual function. Like I think that's just a terrible idea. All right. Okay. So the main ideas, like I didn't rehearse this.
I was just going to
This
say
is
that you and Alan agree on the inheritance.
What?
yeah.
No. I am actually writing a library for inheritance in my language. You know, it's not that I'm not implementing inheritance. I'm just don't want it in the main language because, you know, it's so.
Mm.
I mean, there are reasons not to have inheritance, but like I want it somewhere in the language. I just don't want it
No,
in the main.
Give me 1 second. I just want to update my website. My voice is
This is a
still be
live
going.
demo.
Live.
Yeah, 2 million lines per second live.
So what was amazing though, Levo, is you're sharing your screen, so you've got Zoom in the background. So it's like we're actually seeing ourselves talk on your screen, piped back to us, so compressed on both ends, piped over the internet both ways. And it's still very low lag.
Yeah.
It's almost like it runs at some fraction of the speed of light or something.
Wait, is my screen still being shared?
No.
Nope.
All right, I'm gonna reshare.
Hmm.
So it sounded like you had a mechanical keyboard with brown switches. Am I right?
It's just a really old keyboard, and maybe it's just a little stiff now, banging on it so much.
Hmm.
Okay, yeah. So this is actually like my website. Like yesterday, I kind of like didn't want to put spoilers on it, so I could actually give you like the high level overview and more goals and such.
Mhm.
Yeah. So I had like a lot of goals. I wanted this language to be feature filled, so it's like not a hassle to write very common things. So one of the things I wanted to get rid of was if statements. So instead of breaking outside of a function and then doing if like setting a variable to say if you found something or you're breaking out of the function and then checking it immediately after the loop, I thought that was just like an easy way to like put in a feature. So I have on break and on complete. So yeah.
But on break and on complete, what are they referring to? In this case, there are only one for cycle here, but if there are more, what will happen? If there are few for cycles.
I think they're tied to the for. So, it's kind of like if
Mhm.
has an else tied to it. It looks like the on break and on complete are tied to the for.
Yeah, you can think of it as a else on like an else on an if statement.
Mhm.
So if these breaks are not executed and it completes the loop, it'll just execute this. So instead of having like a lot of ifs after the loop, it's just I find this like significantly more readable. I also um, dislike how many languages just do like for variable in and not let you have an index. So this is actually optional.
Mhm.
So yeah, readability.
Mhm.
Yeah, this is being changed tomorrow. Instead of saying for instead of saying over 480,000 lines per second on LLVM, it's going to say 2 million lines per second. And
Yeah, make sure
you-
you say lines because 480K, you don't know if that's kilobytes or 1,000 lines or
oh right,
kilos of
yeah,
cocaine or whatever.
yeah.
Hmm.
And the reason why I was focused on Mac yesterday is because this actually runs 2 million lines per second on a Mac laptop.
Mhm.
So it's not like a big beefy. It's not just on a big beefy like CPU. It's like on a laptop you can get 2 million lines per second.
Yeah, I mean, you
So
said
that's actually
you're running an
what.
M2, right?
Yeah, that's actually
Yeah,
what impressed me the most. Like I actually get that much performance out of a laptop.
yeah,
So
but M2 is pretty much faster than
yes, it
high-end
is.
Intel.
That's exactly why I picked that laptop up. And it's also like it's pretty nice to have like hardware that it's like mostly standard. Like everyone can get an M2 and you don't have to like worry about like what kind of RAM chips they have and
Mhm.
GPUs or drivers that interfere.
I see types are optional.
What do you mean by types are optional?
In the you
There's
don't
no
have to
type
write it.
annotation on some
No
or
time
V
annotation.
or I or
Correct.
Mhm.
Correct. So you know what? Let's go to quick start. Yeah, so
You are matching Cliff's syntax. I believe he uses the same with the equals and colon equals.
yeah, but the equals is immutable.
Uh-huh.
Yeah, so I don't know how many people will get upset at how you mutate variables, but it's dot equals.
That's fine. You chose it that way, so
Yeah. Well, I'll let you guys read this code. Yeah, ask questions.
So what's the sort of core compiler technique that, or set of techniques that you're using at the high level? Like I get the goals and stuff, but I'm more curious about, you know, what you're doing internally.
I have
Than,
no idea how most compilers implement their code.
Mhm.
So I have a rough idea. I can probably roughly explain what I do, but I have no idea how it differs from other compilers.
Yeah, no, just explain what you do. I mean, we can sort of compare that to what we each know, which is probably all different.
Well, I'll tell you something that's different, and then I can answer other questions later.
But I'm not so
So-
interested in difference. I'm interested in like, what is the technique in a more straightforward way?
Well, I prefer to start with RAII bounds. So earlier I showed that if you go out of bounds, it will complain.
At
So-
compile time specifically.
Yeah. So one of the things I do is when I get an array, even though it doesn't know what the size is, the compiler will force you to check. So in my type system, I actually have a couple of fields, and one of them is, did I compare it with 0? Like specifically if it's above, equals, or lower.
Mhm.
And did I compare it to an array? So over here, you can see that I do array size is bigger than or equals to 10. So instead of associating the size with the variable, I associate a literal with the array. So at this point, the type system holds that the size is known to be bigger or equals than 10. So when I access an element that's less than 10, it will like say that's fine because it's impossible for this to be out of bounds. And 9 is above 0 or equals or above 0. So yeah, so the type system just like holds a bunch of flags and a couple of data. So it holds
So
like
when
if it's
you
positive, if it's negative, it'll invert its if you do a return, it will invert it. So I haven't practiced this part, but what's your question?
So just to go back to the size thing you were talking about in the previous block. So
Mhm.
yeah, that if a.size is greater than or equal to 10, so
Yeah.
then the information that a is guaranteed to be at least 10 is attached to a at that point.
Yeah.
And then does that information get removed from a at the end of the block?
No, just because there's no return. Oh, actually, wait. Yes, it does, but I think I had a quarter case that sometimes it won't remove it, but for the most part, yes, it will remove that information. It will also remove it when you mutate a. I haven't. I don't believe I implemented like if you push a value into a, I believe I invalidate the association. So if you push, this will complain that it doesn't know if 9's in the array. But I don't 100% remember if I did implement that.
So if you make any change to the array, then all of the metadata that you've captured so far is wiped?
Yes.
Mm-hmm.
Yeah. The compiler's been in beta for like maybe 6 or 7 months. So I haven't had that much time to work on it, but yeah, I got stuff done.
It's just interesting. So I'm more, I'm not looking for edge cases or bugs. I'm just kind of interested in how you're doing it.
This
So
this inverted check is I find very useful. So earlier I just check if it's less than equals than the size, or well, I
Less
check
than.
the size,
Mhm.
but the code actually looks at returns and knows that it can invert the check at the since at the end of the block, like it has to return, so it knows it can invert the check. So this actually becomes a less than size, which will let me do the access the array.
So, quick question. You said that you don't use either GC or reference counting. So how do you know at the end of this that you can free, where do you, because it sounds like your compiler is actually putting in code that releases the allocated
Yes.
memory. So what is the model for knowing that something is freeable?
It's part of the metadata. So it's too bad that Cliff isn't here because I know he has things to say about memory. But one
That
of
is
my
true.
goals was taking away memory management from the programmer, not just because it's line noise,
Mhm.
but also so I can optimize the memory better. Because if you're doing like 5 nested splits, it would probably be better if I like pre-allocate them all and do it and know when it can just like reset it all instead of like doing it at runtime and malloc and then free, malloc and free. Like it's yeah, I wanted to see if I can optimize memory, and I got some stuff done. It's not like the optimizer is like very small at the moment, but if you do I to A, it will pre-allocate the memory. Well, actually, it will just put it on the stack, and then just pass a pointer into the function, and then the function will use the pointer as the buffer instead of like returning data. And the neat thing is, if you do structure.member equals I to A,
Mhm.
what actually happens is I to A will get the address of the member, pass it in. So there's like no copying. The I to A will directly work with the structure member. I don't know if that sounds complex or not, but it's kind of intuitive when you like try to understand it. But yeah, I haven't written anything up or tried to explain it yet.
Can you give a short introduction of your type system? What types do you have? Do you have generics? Do you support, we talk about inheritance?
I used to have templates. I took them out because they were behaving similar to how C++ templates behave. A lot of code bloats. I did not want that, so I disabled it for the moment. Right now, it has strings, variable length arrays. It has so the 3 arrays I have is fixed length, growing arrays like a C++ vector, and it has the slices. So you don't know the size of it, but you can't grow it. So all 3 have the array checks on them. There's strings, which is also kind of an array behind the scenes, but if the string is less than 16 characters, it won't alloc. It will just like because the slices are 16 bytes. So if it's less than 16 characters, because null, yeah, less than 16 characters, it will just like inline it. So that was actually very difficult to code. That supported too. Yeah, it's just mostly like bool, floats, ints, and then arrays.
You can define a new types? Or
Yeah, structures are supported as well. Yeah. So let me just go to. Oh yeah, there's also enums and bit flags, as you guys saw earlier. Yeah. Constructors and destructures. Oh, I don't know if what you guys, how you guys feel about properties, but that's implemented as well.
That's in Cameron's department.
Well, this actually looks a bit like C#. I would guess that's what you modeled that after.
You know what? This is actually incorrect code because if the compiler is not complaining about no braces on the else, it should complain about no braces. It's only returns that don't. You know what? Let's run this. Let's see if. Yeah, this must be stale code, but let's see what happens if I try to run this. Oh, it compiles, so that's definitely incorrect. It should not be accepting this.
I don't think you pasted it in. Go back. Did you get the whole thing in the when you pasted?
Yeah.
I guess you did. Okay.
Yeah, so that's definitely an error. Like that should be an error. I really dislike no braces after an else is like terrible. Or if there's no else, this should also be an error. But since there's an else, I let it slide.
So so how do you know? Because I see the RAII there, so I can imagine how that works. But how do you know in a general case when something can be freed? So maybe it's allocated in one function and then passed to another and so on, maybe stored in
So-
some data structure.
I'm just gonna look for a better example. The specific syntax I want to show, but I guess I don't have it on this page. See, the thing about coding all day and night is you kind of forget about the things you did last week. And I haven't looked at this code for like months.
Mhm.
So
That's okay. I tend to forget what I did the day before, so not a big deal.
yeah.
No, I mean the reason I'm asking the question, just to be clear, is like there's
Okay.
I don't think there's generally a known way to do what you're describing. And so either you've come up with something really clever, which is cool, or you've constrained the capabilities of the language to make it easier to detect when something can be freed, which is also
Yeah,
cool.
it's the latter. Okay.
Okay.
So what I want to show was
Or, you know, and of course the other possibility is that it doesn't actually work right, you know, so I'm not suggesting any one answer. I'm just
no.
curious.
Okay, so this is the syntax I want to show specifically. So if you do $ and then a type, you could actually just
Oh, this is looking like Cliff's language.
I haven't seen AA or whatever he's working on.
Well, next week he'll show it. All right, so
I'm
$ABC is what?
I'm just going to show the 3 different ways of I don't remember what works and what does not. So assuming ABC has only 3 members, you can do this.
Mhm.
And if you specify only 2, it will give you a compiler, just like
Mhm.
not specifying all the parameters
So that would be
of a
like
function is.
that's like a constructor. So you're allocating
Yeah.
a new instance of a structure or class called ABC. Is that the idea?
Yeah.
So the $ is the new?
Yes. But the thing is, if I didn't want to use new because people associate new with malloc. So what happens here is you don't actually know if this is constructed in the stack or the heap.
Mhm.
The language will do it for you.
Mhm.
So like when I was saying earlier is name member equals. So over here, what actually happens is actually this is my comments, but there's no pointers in my language. Actually, you can use pointers in the standard library, but not outside of it. But anyways, the way this works is that I2A will, well, name.member will be this hidden parameter.
Mhm.
So when you call I2A, if the variable is on the stack, it will just use stack. If the variable is a member, it will just whatever name member is, that's where it will write to it. If you have like if I2A needs like 1,000 kilobytes like data structure, it'll just the language will automatically say this probably shouldn't be on the stack. It'll put it on the heap. Some of the metadata, like I was talking about earlier, tracks where something's been constructed and if it has a constructor. I mean, where something has been allocated and if it has a constructor. So a raw array doesn't have a constructor, but it does track where it's allocated. In this case, it knows that we're not making a new variable, so there's no allocation happening. But this could be like on the stack on the heap, depending on how this is defined. So I2A will never like alloc because it's just I2A. And
Right. So I2A is basically rendering the integer as a decimal string, correct?
yeah.
Okay. So that string of characters is going to go somewhere. And what you're saying is that name.member is itself a field with a substantial number of bytes that can hold whatever I2A spits out. So are you passing the pointer to name.member to I2A so it stores its data there, or are you storing the location that I2A allocates as a pointer in name.member? Uh-oh,
I cannot hear you. I'm not sure if it's my side or not.
I think it is.
I can hear you fine.
I can hear fine.
Oh, I missed the question. Can someone repeat it?
I wonder if you're running out of bandwidth on Zoom, so maybe minimize your browser just so you're not
I'll stop my screen share.
sure.
Wait,
Yeah,
am
what
I sharing my screen?
You were. So Levo, what I was saying is it may help to minimize your browser to reduce your bandwidth utilization because it was piping a picture of me talking back to me.
Oh, right. Yeah.
Sorry, what was does anyone remember what was asked?
The
Oh,
dot
yes.
the dot member, is it?
Right. So you had name.member equals. So the question is, where does I2A render the bytes to? What memory location? Because
Okay.
you were suggesting that it's not allocating one. Okay.
No.
That means one
So-
must have been allocated before you called it.
So what the compiler does
We're losing.
is
We're not getting good audio from you right now,
it
Levo.
sees. So when you call it's assigned to, and since I2A is saying it doesn't want to, when the compiler looks at all the function signatures,
Mhm.
it will. Okay, so the return value is actually a car.
Basically
gonna,
breaking
like-
up for me. I can't hear anything. I can't make out anything that's
Yeah,
being
it was
said.
the audio was breaking up, Levo.
Okay, I simply asked if I'm still sharing my screen. I'm
Nope.
not sure how to turn it off.
You're not sharing your screen. You turned it off.
Okay. I'm gonna just copy paste some stuff. Does Zoom let me turn off video? Maybe not.
Your
You can,
video's already off.
Okay.
right.
You can share the example code in the docs. I will share it again. So
The other thing is if you want to dial in from a phone for better audio, you could do so using the number that I put on the invite.
I have no idea how to do it. If you guys can still hear me, I'll
Yes.
just try my luck with text.
So
Well, we've been talking about Bolin for an hour. I don't know if we want to move on to any other subjects. Or keep on going.
If you guys can hear me, I'll happily answer that question. It should be a very simple answer now.
we can hear you. Go ahead.
Okay, perfect. So one of the first, the second pass of my compiler is to look at all the structures and function signatures. So over here, you can see that the return value is a car21.
Mhm.
So the compiler will say, okay, 21 bytes is definitely, it can definitely put it on a stack.
Mhm.
It also will say, it knows that this I2A is accepting this as a pointer, as a hidden pointer, because it's not asking, there's no ownership signature on the function signature. So it's just saying that this is something it will return without allocation. So what happens is, before looking at the body of anything, it knows all. Wow, I haven't talked about compilers for so long. Because it's because all the types of function signatures are known,
Mhm.
when it looks at the body, it knows this function wants to return, is accepting a pointer, and it will just return data. So when the compiler gets to variable equals function, since it knows the signature, it wants like data to be passed in, it'll pass in whatever you're assigning it to.
Mhm.
So in this case, it will not compile if you don't assign a value, because then it has no pointer to pass in. So yeah.
So basically, someone is passing into the function a pointer to a buffer of at least 21 characters, correct?
Yeah.
Okay.
So
And
the
that,
compiler just knows, will type check if your variable has at least 21 bytes,
Mhm.
or if it's just on the stack, it'll just put it on the stack for you.
now
So
what
if it's a
if,
structure, it has to be at least 21 bytes.
right. So there are a lot of things obviously in software that don't have a predictable known size, right? So how do you deal with those
So
sizes that aren't known at compile time?
yeah. So I haven't ironed out all the signatures, but two would be it returns a slice, and another one is it will say own, as in you're returning the own, you're returning a pointer that the caller must own.
Mhm.
So actually, there's something else I want to show,
So
but
that's kind of transferring
So-
responsibility for freeing it back to the caller is what you're saying.
yes,
Mhm.
yeah. So the compiler actually has a graph of like where something should be allocated and where the lifetime ends, and construction and destruction happen separately. So if you're in a loop, it will just allocate once and construct many times if it needs to be.
So what I hear are the concepts of ownership and lifetimes being tracked inside your language.
Yeah. There's actually one more thing I wanted to show. If you guys click on the link, or maybe
Sure.
someone else should screen share.
I will
if you-
share, I'll share my browser so people can see this on the recording anyway, since I assume everyone there can browse things. So Firefox, Bolin highlights, here we go.
Yeah, so I just want to show the first function, or the first code sample.
Okay, so the first code sample is the one that says function parameters, returns, and strings.
Yeah. The sites dynamically changes if depending on the dark mode or light mode of the system. So if you guys can't read that, you could just browse in.
So what did you
Yeah.
want to highlight out of this example?
Just take a second to read it and ask me questions. And if no one asks, I'll just point it out.
So you've got an example that returns 2 integer values, and the example 2 returns 1 integer value.
And something with the c dot equals 100. That assumes it's
So it
it's in-
assigns a value to an out parameter C, that one.
Yeah, B is also is kind of like a ref, like in and out.
Mm-hmm.
Yeah.
So it's
So the key thing I want to show is if you look 2 lines below the last comment, it says return value equals example 2. If you'll see that the second and third parameter have markers on how they pass data. I thought this would make things more readable. I don't know what other people think.
it doesn't really detract from it. So I mean, it seems to have to match what was in the in the function declaration. Is that true?
Yeah.
So it's kind of an additional redundant. It's redundant, but it's in the call site instead of the function declaration.
Yeah. So the thing I noticed in a couple of code bases is sometimes people design APIs. They don't design them that well, and a function that sounds like it won't mutate any parameters it does mutate. So this is just so like you're not blindsided of like what's mutated and what's out, and you don't have to initialize. So, yeah. But yeah, so that's all the key things I want to share. I shared.
All right. I will stop my screen share. Did we lose Derek? I think he may have had to leave, unfortunately. Okay. All right. And did we lose Aaron?
Seems like a lot of snow these days.
All right. Who is Ian Rogers? Is that? Hi, Ian. Hi. You want to introduce yourself? I can't hear you, Ian, if you're talking.
Sorry, I have
Oh, there you are.
And I have to remember to switch it on. Yeah, so I'm Ian Rogers. I work for Google. I worked with Cliff at Azul Systems. Before that,
yes. So you've been on the discussions. Yes.
on the Discord, yes.
Excellent. Well,
on Discord.
good to put a face with the name. So you said you're currently at Google?
Yeah, I've been at Google for getting on 12 years.
Wow.
So yeah, I joined originally the Dalvik team from Azul and so on. The comments on the out arguments and the mutable stuff, I found that interesting. So Google had a thing about in C++ about reference arguments that you shouldn't use them. You should prefer pointers. And the reason for this was to make it explicit when you were calling a function that you were passing a pointer to something. And then there was a scourge of kind of like segvs, null pointer exceptions. And so that convention was weakened. But you can still see the convention in languages like Go, where they mark their out arguments. And so it's interesting to me that kind of like it evolves over time what people think is best. personally, I've been bitten by reference arguments, and I always liked the explicit ampersand. So,
Right, because in C, well, C++, when you're passing a variable and it's going to a reference, you can find out that your local variable got changed by the thing you're calling, and that was the concern, I assume.
yeah. So, an example of a compiler that Cliff and I worked on, on x86 you have Rex prefixes. So when you're generating an add instruction, you need to worry about, does it have a Rex prefix on it? But maybe you want to generate more than one instruction. And so the Rex prefix was a reference argument, because you may not have one, and it may get updated. But one of the effects of that was to mutate the registers and to strip bits off them. And so you'd end up with this behavior where, the first instructions were addressing the high numbered registers, but then kind of like the reference arguments have been mutated, and then the lower numbered instructions were using the low numbered registers. And you only got bitten if you happen to pass in a high numbered register. And from the caller's side, you couldn't see what was up, because you were assuming that you were just passing values to these assembler routines and so on. So it's yeah. The problem with C++ is that there's what people say you should do, and then there's what kind of like the standard libraries are doing. Google has a thing in their coding convention which says that you should never make anything unsigned. And of course, the standard libraries disagree on this, because strlen is going to give you something which is unsigned. And so most code in Google is compiled with signed unsigned comparison warnings disabled.
I prefer signed as well. What's the reason for not wanting unsigned? I do use a lot of unsigned though. It's hard for me to imagine what the people who come up with the convention, I can't speak for them. There are some cases with signed, because overflow isn't defined, you get more undefined behavior. There's more potential for compiler optimization, because you haven't got to worry about, if this thing is used as an array index, will it could it potentially overflow? Did I mishear you? Didn't you say that Google prefers signed variables?
Yes.
So there's more undefined behavior.
Yep. Yeah.
No, I prefer to. I prefer to.
It grates me in places where where somebody's taking a standard library and then wrapping it with something where they're changing everything which is unsigned to signed, and the things that they're changing are things like the alignment. Because I want to align things to -8 bytes.
That's interesting that it reminds me, because at work we just explicitly don't use the standard library for C++, mainly because of template reasons.
I didn't know that C++ had a library.
That's fair. we don't use the STL, so it's just like we find that the STL has impeded backwards compatibility in many ways for us. And it's actually a fact, because I got really very angry a couple days ago, last week, when I was working my compiler about a template error that I just couldn't unwind. I was just like, I don't know where this is, and I couldn't figure it out. I'm just like, you know what, screw it, time to just rewrite the compiler. I'm done with the lost cost fallacy of this. It's just to the point where it's just like the language. I started my compiler because I got sick of dealing with C++ template errors, so I decided to give myself more simple C++ template errors to write my language. So it's just
There does seem to be a rather large number of languages that are written primarily because people hate C++.
It's a love-hate relationship. I love what it lets me do. I really do. Like, when I first started Java 10 years ago, or first started programming, my first language was Java. And then I started doing C++ for game development.
Mhm.
And being a C++ developer has made me a better Java developer.
Mhm.
Mainly because I think there's this huge loss in knowledge that's happened, or maybe that's huge loss in knowledge, or not really loss, where you're not given the opportunity to realize.
Zillions of things you do not have to know because you're using Java. Yeah, so Java was a really nice language to come to from C++. But I wouldn't want Java as a first language.
No, neither do I. Like, I know a lot of people who start like get into Java through like Minecraft modding development. And there's some issues with there's some issues
Anthony,
with that, but it's
were you around when I mentioned templates in my language?
no.
So I removed templates from my language because I did not like, I didn't want it to be like C++ templates. So when you said the errors, I thought that was funny. I completely forgot to say this, but it's not even important. But I do use C++ to run my compiler, but I actually compile with no standard library. So it actually, the binary does not depend on libc or libc++. It runs on all the Linux distros because it does not depend on C++. So yeah.
Something I've been wondering, and because this has just been because I've just been in this weird. When after I was in my angry fugue state about how I was trying to figure out how to get the compiler to be cross-platform, like cross-compilable, like Go.
It was a pain, but go on.
I think Go has one of the best Go has one of the best tool chains.
Yeah, I've heard a lot of people say that it's like super easy to get started with.
Yeah. And, I want that for my compiler, but, I was thinking, it's like, what goes into that? What are the actual things? But I was like, well, you need to have a way to have your standard library reference all of the system calls of every OS in existence. And because, you don't have a stable system call ABI on Windows or Mac, well, you need to
on Mac, it seems like you cannot have static binaries, so you must use like the Mac runtime.
Yeah.
Windows, I believe you can use no standard, or you can use static libraries, but they're going to inject their DLL anyway.
Yeah. So like I was wondering, like at the loader level or at the assembler level, like if I just have like a giant call list to their C APIs, and I just do a transparent, just like, okay, well, when I'm doing that, let's just stub this in the linker level. And then I should just be able to compile it to that target.
You're talking for Mac specifically, or
just any OS? Like they don't like Mac is a weird issue because their API isn't stable in any way because it's Mac. Windows has the best backwards compatibility out of any API I've seen. Win32 is insane.
I wrote a prototype to do this, but since it's not my actual compiler, maybe someone else is better suited to answer.
It was just like some weird thoughts I've had about it because it's just I am tired. There's this tired development that I have of where we have to buy 3 different operating systems for one that's going to be, let's say, $1,300 if you want a laptop to take around with you, another one where you have to spend $100 for it, and then one where you have to figure out which one of the thousands that you want to download in order for you to actually compile on. So it's really just like I just want to have build dot and then just have it run and be able to spit out all 3 operating systems.
So you want Python?
Well, no, I want it native.
The problem is Apple is ARM now, and the other systems are likely not ARM.
Oh, I mean, if you're on the server space, it's ARM all the way.
You mean x86 all the way?
Well, I think there's a huge amount of ARM and x86 mixed together now.
Oh, I thought the most servers were Intel.
Well, they
or Intel-based.
traditionally have been. The ARM is really just making its first big foray to the last couple of years into the server side.
'Cause the only host I know of that provides many ARM servers is Amazon.
Mhm.
Like I could not find them on other providers.
Yeah, I'm just like speaking from like internal systems that I can't speak to right now for work.
Mhm.
But it's like there's this huge push on ARM for ARM systems, mainly because they like the bill that they get at the end of the day.
So what were you going to say, Ian?
Yeah, you can get ARM on Google Compute Platform. I should speak up for my employer.
Is there a particular one of the big ARM server names, the blade names that you're using, or it's just generic ARM?
So, all of the things are basically Neoverse processors,
Mhm.
but they're combined with other things and then sold on.
What are your feeling about having some kind of bytecode to generate binaries from instead of like using a native binary?
I've been speccing out like a pseudo assembly that I can translate to whatever. So it's like a bytecode.
Earlier, I doubled my language and it does 2 million source lines per second, like 2 million source lines. So I'm sure that you can probably generate assembly pretty quickly from bytecode.
Right now, it's just a matter of I just need to sit down and just re-architect the compiler. Like the biggest pain point was when I designed it originally, it wasn't really designed to do self-tests that well. And after about a month or two, that was just, I was just kind of over it. But I was already deep into the compiler and I'm just like, you know what, no. So, and then after the template error, I'm like, you know what, there's enough pain here. Sunk cost fallacy, go away. Just rewrite the, just rewrite the.
So Ian, are you
How many
currently working?
prototypes did you write?
Of the compiler? Right now I'm on my third prototype. The first one was originally a TypeScript to native. And I was like, I don't want JavaScript in this anyway. So I gave up.
Can you share your goals about the language, Anthony?
Oh, 1 second, I have a phone call.
Oh.
So Ian, what are you working on now? Any particular language or compiler?
No languages. So I work on the Linux perf events subsystem. So it's there's a lot of people who want to convince you that their garbage collector is the best, or their compiler, or their runtime is the best, and I can wear lots of different hats and argue for all of them. And so I have a role doing that. I'm the RISC-V vice chair for managed runtimes.
Okay, I'm sorry about that.
So I was interested about the comments about kind of like a universal binary code, because my PhD was on binary translators, and this is back when you did a PhD by actually having to go to libraries to find references, and I know that the idea of a universal binary format is kind of something which has gone round and round.
Well, we have 3 of them now, right?
Well, that means we are like what? According to XKCD, we're 11 off from the perfect amount of standards.
Right, but we have WASM, we have LVMIR, and we have JVM bytecode. And I think those 3 are probably each in their own way pretty near universally portable, right?
4th if you count C, but maybe you shouldn't count C.
Well, C is the ultimate assembler.
That's what I used to compile 2 million per second.
Yeah, the problem with C is it's portable in name only,
I say, yeah,
as
I
in
say-
the C name is portable everywhere, but the actual code less so.
I say the same thing about C++ all the time. That said,
Yeah.
there are some really nice C++ features that have been added that I really like. It's a shame that it's bogged down by about 20 years of everything else.
Yes, there has never been an idea that Bjorn said no to.
So what's by the way, I wrote my language to replace C# and other high level languages. So I'm not trying to replace C++. It's just everything else. What do you guys like about C++, if anything? Because honestly, I mostly use C++ like C plus like construct like RAII.
Well,
Pat?
I'm working on Linux kernel code, and not having RAII is something that I've had to invent strategies around, and I'm dealing with bugs in code because of a lack of RAII. And if somebody can find a better way to do RAII in C, then I know there's been proposals for defer, but defer doesn't really appeal to me that much.
I mean, to
Why-
me, C++ is, it's like juggling chainsaws in a razor blade store. I mean, it's pretty cool, but I don't do it for the fun of it.
To me, it's, I just like that it's C with scopes, or at least that's how I use it.
Yeah.
Because whenever I try to do anything bigger, it blows up in my face. And I don't mean that in a bad way. Like,
No, but by scopes, you mean hierarchical nesting of
Yeah.
scopes, and it's very good at that. That's what RAII is
you know,
perfect for.
like, I'm mad about how some things are implemented. I would love it if I would love it if I didn't abuse the fact that structs are classes. I would rather structs still be structs syntactically within the language, but I understand why it's not.
So in the chat, Matt said, I honestly prefer templates with matrix multiplication conformability being checked by the compiler, as in matrix NM times matrix MK, rather than having to wait for the errors like this until runtime. So that was in response to C++.
To me, likely.
Ah, okay. Oh, I see. To the operator overloading comment. Yes.
I was debating about adding operator overloading to Minerva. I just don't know how I would do it correctly. So I just left it out. Same thing with generics.
What do you mean?
It's like, I don't know how I would want it to syntactically work. So I just left it out until I can figure it out.
Do
Same
you have
thing-
function overloading?
Yes.
For me, for my language or my compiler, it's basically the same thing. I think it actually reuses the same code.
Look, the idea so far is if I don't know how I want it done, I just leave it out for another day.
Oh yeah, for sure. I thought it
generics-
might have been an implementation problem, like how to actually write the overloading code.
Something I really did stupid, and I'm glad that I know this now, is because I was like, well, let's try and make this really smart and performant. So let's just create a job task. Let's read in all the files and giant threaded queue, and then just do all the parsing and type checking, do a first pass type check. So I can do everything all at once and then just collect them all together. That's fine, but when you don't design your compiler to where you can easily bail out of that and go to I want this to go, and I don't want you to be threaded. I want you to work in a synchronous way, so that way I can test things easily. life gets very, very difficult really fast. And then once you start running into type checking bugs because you don't know where things are anymore, then, you know, like, let's not do that. You know, it's the parser is the easy part. It's everything else that then becomes. And I
Yep.
wish I learned that like 2 years ago when I originally started specking out the project.
Tempted to say that type checking, if you're supporting complex type, is one of the most difficult things to get right.
I agree. The two hardest things for me was the type checker and generating the backend code.
Generating, yeah.
Like
Yes.
when you can't even enter main because you did a mistake somewhere, like you can't use printf, can't
Right.
do anything. You have to look at the assembly, and that can get rough.
The two hardest things for me were off by 1 errors.
And naming things, maybe.
Naming things is hard. It's finalized. Naming things is easy. It's finalizing the names for everyone else. And then the arguments that happen, that's the real hard part.
That's equal to making an interface.
So, Matt, you're working on a compiler, if I remember correctly, for a company that you can't name. Is it a C++ compiler or it's written in C++? Seem to both. Interesting. Okay. It's for C++ in C++. All right. So that would definitely explain some of the
So eventually it will bootstrap your C++ in your old C++,
or it already does.
or already
It
does.
sounds like such a pain to write a C++ compiler.
All right. Ian's dropping. Theodore, any updates on your end?
No, I haven't written a line of code in 6 months, so no much. I have other things that are pressing at the moment, and I don't know when I will come back to write. That's kind of that would lead me to, as time passes, to evaluate my ideas about what I want in the language. I have 3 specific ideas, and unfortunately I can't share anything because they are ideas at just the moment. A few prototypes and how would that work and what would that buy me, and until I test it and see, so there's nothing much.
So they're language ideas or implementation of the language ideas?
Language ideas. And a few implementation experiments that I don't know where would lead it. I remembered on one of the CCC you said that there's what there is to be invented is invented in programming language. I have a few ideas that I haven't seen anywhere. If they work, I will prove you wrong, maybe.
Good. I like to be proven wrong. Well, the other thing is sometimes one way to do it is to actually just write it as if your language already existed, as if the compiler were already written. So you write the source code as if you had the full tool chain available, even though you don't. And then it allows you to kind of look at it and reason about, is it actually going to be able to accomplish what I want it to, right?
What I would say, I know the concept is fruitful because I have this concept in the Scala library. That's where we incepted, and I quickly thought about that. Its place is not inside the Scala language; it's in a language feature that would start. Well, I I wouldn't write my own language and test it out. But I know it's working. I know what it's capable of, and maybe it will turn into something new.
Question from Levo in the chat. Everyone tells me Go compiles fast, but I measured it roughly as slow as GCC. You mean as fast as GCC? I'm joking. Clang is faster than both GCC too, depending on the platform. Did Go get slower or did GCC plus Clang get fast? Clang was pretty fast from the start, if I remember correctly.
This is secondhand knowledge that I have, so I could be wrong. If I remember right, they implemented like an SSA form into it, which
Mhm.
actually slowed down the compiler a tiny amount. Just
When was that?
that was like a couple years ago.
Do you know what version?
No, I don't use Go enough to track that stuff.
Oh, I don't use it at all.
I would
So-
like to add a pinch of salt about the fast compiler times, because when Go is adding generics now, the compiler times are inevitably getting slower.
Yeah.
So there is a pinch of salt, and what are you compiling as fast as you would?
There's also I think there's like this weird, like your compile time, like I think there's the same thing that I would want is I want my compile times to be just fast enough to not be annoying if I have to recompile.
That's an excellent way to put it. A lot of people think that compile times being fast is the goal in and of itself. And it's like, no, the goal is that how your language get used, your tools should never be frustrating to the user.
It's like it's this impediment because a friend of mine, he's trying to develop a text editor because he's sick of IntelliJ and he wants the modability of Vim. But he wants like IDE like features. And you know, and this is something I learned in game development is, you know, when you're thinking about performance, it's not always about, you know, how many cycles that you have, you're not always trying to count cycles to the CPU. It's you need to include the user as part of your performance metric. If it takes like a couple of seconds for something to appear on screen and then it appears, especially if you're in a text editor, you expect it to be there instantly. But if there's a second, then like your brain just does not understand how to compute that. So like,
did you say you do game dev or
I
you
used to. I got out of that a long time ago because frankly, I just hate users.
I always was wondering, not including the game engine, which you probably don't modify, how large was the actual game code? Like the source code?
Including the engine, because we used an in-house engine because we didn't want to pay Unity
I
or
see, okay.
whoever, which was a smart decision because it actually made it more cross-platform. I mean, it was like no larger than 100,000. It wasn't that complex of a game, but like, so long as you understand like how the systems are built, like, and then we could, for that one game, it was.
How long did you wait? I'm assuming you're not compiling with sanitizers.
I don't remember. Like, it was awful. That's all I remember.
Oh, really?
It was
I thought
awful.
with 100,000 it would be like a second or two.
It was
I mean,
generics.
oh,
Yeah, generics do that. It's where my hatred of generics came from. And then, or not generics, templates. But
C++ generics.
yes.
C++ and
And then like to make our lives not suck as much, what we did was we just basically created just a C struct that we passed around. We just created a bootloader called Pirate because, you know, you store your booty there. So then basically we just passed like the entire game state to the bootloader thing and then just did the recompile and then it just like went back there. So we could just have a hot reload. I really wish there was a way to do better cross-platform DLL loading than than that, because doing that in a cross-platform way is impossible. So you have to build essentially 3 different implementations of bootloader. Or what you do is you just like, screw it, X turn C, and then.
Besides my joke of using C as a virtual machine,
Portable
is th-
assembler. Yeah.
Is there any bytecode that does not require a VM or garbage collection?
I mean, there's the bitcode for LLVM.
Yeah. LLVMIR.
Oh, right, right.
Technically speaking, Go assembly is a bytecode. And then it's just like Go's assembly, like it's assembler, it's like assembler and linker are something very interesting to look into. Or look into the Plan 9 linker if you really want to, I think, understand it.
I support LLVM's text IR, but I never actually heard of anyone using the bytecode directly. I also know a lot of people use the API. And they all say they dislike it.
Oh no, it's awful.
I didn't want to touch the API. I figure like if the text IR gives me everything I need, I should just go for that.
I was reading someone's statements on the C++ API for LLVM IR, and they really liked it. And
I think people hate the C API more than the.
I don't think they have a C API.
It's just
remember
not
someone
stable.
saying they used the C++ one just because they couldn't use a C API.
I mean, that was part of the original reason that before I found out there were Java bindings to the LLVM. And then I decided to abandon the LLVM in favor of my own assembler format, which I'm probably going to hate in about 4 months.
you're going to be like, whose idea was this?
Yeah. Oh, what's that saying about, it's like, oh, well, that's future me's problem. Screw that guy.
Or the saying about the lawyer, only a fool would have, only a fool would have himself as a client or something.
Well,
a man who represents himself in court has a fool for a lawyer and a jackass for a client.
There you go. That works.
So it's like,
I've heard it attributed to Benjamin Franklin, but have no idea if that's true.
Oh, Abraham Lincoln said he said it, so the quote must be true.
So I also wanted to hear from Alan, because we haven't gotten any updates from him in a while.
Oh, well, I've been kind of sick, I guess. That's the update. I haven't really done much besides.
I think you're just making excuses while you're growing your beard big enough to be a language genius.
No, I trimmed my beard. It's not got growing anymore.
You saw
it's growing now because I'm sick, but I haven't been trimming it. But
you saw the study though about languages, that all the good languages are made by people with big beards.
Oh,
that's why I don't make progress. Yeah.
So
man, my prototypes.
I wanted to ask Levo, like, have you heard of the V programming language?
Yeah, that's one of the 2 languages I prefer not to talk about, but ask your question.
Well, I mean, I'm just thinking it sounds very similar. Like, like I go to the
dude, that's the biggest insult I ever had in my entire life.
Wow.
Like we can compile 500K lines of code a second. So like, it's like, I mean,
that's a quarter of what I compile. But also last month, I'm like, okay, I'm going to use TCC to use and to compile my source, and I was using line, like the line directive, and it didn't work on Linux. And I'm like, don't other languages use TCC to compile? Like, why is this not working? It turns out it actually just, they didn't implement it, or it broke sometime. And I was the first one to do the bug reports, and the guy fixed it literally like 12 hours later, like after I wrote the report. Like, it was such an easy fix. I'm like, how are these languages using TCC and not like report this? I pulled up a V just to see if they fixed it or if it wasn't a problem for them. They don't have a debugger. Like, you can't debug with GDB for compiled code. and they were like on version like 3 or something, like 0.3. I'm like, didn't I hear about this language like 3 years ago? Like, how did they not have a debugger like all this time? Like, it makes no sense to me.
All right.
I mean, the answer is
I'm not saying that V is like a great language. I'm just saying it has very similar goals to your language.
I honestly, well, there's a lot of things that I honestly thought that V was a joke because the author contradicted himself so many times, like the original posting guy saw. And I'm like, how are these people, like, how do these people think this is real? This is obviously like a satire. And it turns out I'm the fool because it was real. But I'm just surprised that the author didn't realize he was contradicting himself like so many times.
Hmm.
I mean, we're all writing compilers, so in a way, we're all kind of fools.
Well said. Well said.
It's
That would be the quote of the CCC.
yeah.
There's
It's I like it's speaking about debuggers. I didn't realize how much I hated debuggers and how much I actually hate debugging formats. Because I hate dwarf. And I also hate the PDB format as well.
How are you interacting with it?
How am I interacting? Well, I don't code gen right now, so I'm not. The answer is I go into GDB and I interact with my AST and try and figure out things right now before I code gen. But
I think the easiest way is just to use straight C, and then you can turn on some sanitizers if you're not confident in your C skill.
Like what I'm planning on doing is I don't know yet, honestly. I don't know. It's right now I'm just doing printf debugging because tried and true. But until I'm not at the point of executing main, so it's not really a problem for me.
Oh,
Like I'm in the process of a complete ground up rewrite of the compiler. So
I always, okay, so since my compiler is like significantly faster than everyone else's, I was just wondering, how are type systems usually implemented? Because I feel like maybe mine is drastically different from like how they're traditionally written.
First of all, the type system stuff is really deep.
Yes, it's hard.
And hard. It's pretty likely if you didn't minimize your type system to some kind of minimal base that you can reason about it, that the type system bugs are working.
I've from spending way too much time trying to figure out type systems and listening to CCC, I believe everyone implements their type system differently and nobody exactly knows what we're doing.
So
That's
I don't
kind of
think
true.
that's true. I think it's often true, but I think there is actually a fairly standardized core way of doing type systems. Comes straight out of university, and they all look the same. It's the OCaml Haskell Scala type system. If you know what I mean, like they use a certain way of doing.
I have no idea how they work.
Right. That probably means you didn't take OCaml Haskell Scala type system 101 in college.
Nope.
But there does seem to be a very standard way, Pierce, what's the guy's name from the 90s who wrote 17 books on type inference and stuff. Anyway, I mean, they're very, Hindley Milner, going way back, Church, Lambda, all, there's kind of some basic building blocks that you see over and over again. The F, system F,
Yeah, but Church's type system's not very rich. He's just like, it's a function. Okay, we're done now.
Oh,
There's some niceties to that.
we call that C. Right.
C at least has function pointers and value pointers.
But all those type systems though seem to be built on this basic concept of a type is defined by the values that it has. Right. And they always start with this thing of 0 or one more than some other value. So, and that's
very counterintuitive to me.
Yes, that's because you're a programmer, not a PhD student.
That would concern the types that are represented by values, but what about type bounds? What about wildcards? What about abstract types? What about these things are not easily representable by values, and here is where it gets complex. If your type system is like require you to annotate all of your types, you're probably fine. You'll probably, if you don't have generics, if you don't have type bounds.
The craziest thing is I found C to be like the only language where I managed to get a not too insane type system. Because
Right, because C basically doesn't have a type system, right?
Everything is an integer, period.
Well, what happened was there was a moments where I went from C to C# to prototype faster, and so one of the things I do is in my type system, in C++, I can say check this type. Like I'm going to go from this type to that type. There's other parts of the type system, but the main thing is like if I do an assignment, I want to say this type to that type. And if I'm passing parameters, it's the same thing. I'm passing this into this function. I can say, give me a score, or actually do the work for me and convert it. That's like the same function. In C#, I had to make them two separate functions.
That's
because
right.
One returns the score and one actually does the work, and you can't like cast a pointer to an integer for the score.
That's usually weaker. It's in these languages, it's easier to cast one type to another type.
Right. Well, that's the word you just used. The cast is the problem, right? Because it means like 5 different things in one in say C++, right? So cast, like when you say cast, which cast do you mean? Do you mean the kind where it actually adds zeros or takes them off, or do you mean
oh yeah,
or do you have the standard library versions where you're doing a const cast, or
right?
So I return actually have a parameter that says score, so that would just say if it can like for function parameters, it'll just say if it's compatible or not, like it can be converted.
Right.
So if I have score as false, I can still return a score. And if the score is like,
can you spell values. When you're saying score? Can you spell that? Oh, okay. SCORE, score.
Yeah.
I don't know that term used with types, so help us understand what you mean by that.
So, in my type system, I can say if you have a byte versus 32-bit int versus 64-bit int.
Yep.
If it's not the exact same size, it'll say it's either trivial converted or same bit pattern, as in like an unsigned 64-bit versus a signed 64 bits. They're the same bit pattern, but they're not exactly the same because one's signed and one is unsigned.
Yeah, so one gets sign extended and one gets 0 extended.
Yeah, so when I do my overloading, I try to find the function that has the best score. So what I actually do is sometimes I can just be lazy and say this is the exact same type. So I return score of 0, meaning it's like perfect. So even if I'm saying I want to convert something, my type system function can return 0. And then the outer, this is like the internal function, that the outer function will say, oh, this got a score of 0, which means I could just pass a pointer in like without any conversions. So, or I also have a trivial, which is
so
look at
the link that Matt posted in Tudor, if you could put that in the
ranks.
talk as well.
Yeah. It is.
Yeah. So because I can have I can pass since I can return a pointer for the actual work I did, or I can return a value like by typecasting. Like I just abuse C++ typecasting so much, and it just made my life easier because I have less. All the code, all the type system code is like more local to like a set of functions.
Yeah, so I refer to the C type system as the trust me type system. And because it, there are rules, but basically every rule there is, you get to choose when to use them and when to ignore them, right? So it's like, trust me, that block of memory that this pointer points to, it's actually a person struct. No,
I think
just kidding.
the
It's
only
actually a
reason
point
why
struct.
the only
With-
reason why I got so fast is because I can abuse everything. I actually don't use the SDL. I mentioned this already, where I don't use the C standard library.
Mhm.
So since I use my own memory allocators and my own containers, I just was able to make everything fast. And since I know how everything works, the source code isn't even that large. So it's very easy to optimize my own compiler and my own library, since like it's tiny source code, like
Mhm.
less than 100,000.
So we're at about 2 hours, so we should probably wrap. But Levo, what I'd suggest is definitely try to come up with a way of explaining how you do the
Memory
memory
allocation.
well,
Yeah.
and knowing when to free it, because from a distance, it's one of those things that sounds too good to be true. And I'm not suggesting that you're misleading us or anything. I'm suggesting that until you can explain it, it's that that old saying that sufficiently advanced technology is indiscernible from magic, right? So looking from the outside, it's like magical, right? And there's different explanations for why things look magical, but
Yeah.
it would be a good one to explain. So
So one of the things I was thinking is that even if I explain it, people will not care or accept it. I kind of think that it's one of those things they have to like try the compiler for themselves and see if they can break it. So I think maybe just having standard library so it's more usable.
mhm.
Well, would you prefer an explanation, or would you prefer like a standard library and like writing code yourself?
Well, personally, it's kind of like a map with little tacks in it, right? I'd like to know kind of where in the universe of memory management the tack goes for this one. And
Yeah, in a forum like this, saying how you know when something's gone out of scope is nice.
right. Yeah, because most of us have experience doing it a lot of different wrong ways. So we want to know which wrong way you're doing it.
uh, okay. This is like a hard question,
Hopefully
but
it's not wrong.
And
Hopefully.
and by the way, there's when I'm kind of joking, but like it's we all appreciate the fact that people do experimentation in different directions. Like that's what makes this stuff so fun.
Mm.
So
yeah.
so never be worried about going off.
Okay, this is my most simple explanation I can think of, but I got to start with a question. Are any of you very comfortable writing C code without fear of invalid pointers or leaks or crashes or anything?
Yeah.
Like, are any of you that comfortable with C?
Yeah, because I learned C after I knew assembly. So it's like C was
Yeah,
like, wow, magical
same.
guardrails.
Same. But is it just Cameron? Because I would want to ask more than Cameron.
So when I'm writing C, I use Git's trick, which is Git never had any use after free bugs because they never freed any memory. It just ran and allocated memory and did all the data structure manipulations it needed till it was done and then killed the process. So as long as I never free, I'm pretty confident in my C.
My OS is the perfect garbage collector. Allocate 4 gigs at the beginning of time, and that's all I have.
Okay.
But yeah, the only time I get worried in C is when I free memory.
Usually
Okay,
when I write C, I can spot it pretty quickly what's going on. But with a sufficiently large program,
You know,
becomes
Valgrine's
difficult.
your friend.
Okay, so before I wrote my first prototypes to see if my memory management strategy would work, I was pretty confident it would work because when I write C code, I almost never leak memory or corrupt it or any of the bad things. So my thought process was all I have to do is encode the rules into the compiler. And when I wrote the prototype, I just figured out how to do that. But it never felt to me that it was like a difficult thing because when I write C, it wasn't that difficult for me. But I
But
just figured that like
you
maybe it's
didn't.
just the problem domain I'm working on that
Did
it's
you
like just
try
simple.
to boil down your ideas to something that it's already, let's say, it's like the Rust borrow checker, like the rules of some kind?
I just think of it as the way I write C code and not leak, just encode that in the compiler. But really, it's just like uh, you, for the most part, you know when you're moving memory. Like if you're putting memory into an array, you know if that array is going to be destructing it or not. So you know you should not pass that pointer elsewhere
But the
because
caveat is not always knowable. You cannot.
Right. That's the question. I wonder.
I
You know, it's-
refactor my code if it's not knowable.
Hmm.
So I just figure if I make my language strict enough that it'll tell me if or it doesn't
So
really have to tell
the
me, but
language is in the area of statically known all when you allocate how much memory you would need for the something you allocate, and pretty much you know that that's the statically at compile time.
yeah, the only thing it doesn't know is when you push data into an array because it doesn't know how long your loops are. But everything else it knows like the struct size, or if it's a fixed length array, it knows the fixed size. But
Yeah, it reminds me a lot of the things that they said at the very early days of Rust, where they were like, in order to get Mozilla's C++ code to work, they had to come up with very rigorous standardized comments at the top of their C++ calls that said, when you call this thing, I own the pointer now, you don't free it. Or
Right.
when you call this
Yeah.
thing, you still own the pointer, so after I'm done, you're going to have to free it.
I don't
That
I don't
basically
know.
Rust was encoding all of this formalism that was in the comments at Mozilla for how to build the Firefox browser
Right.
into the language itself.
That
So,
explains
no-
so many things.
Yeah, so encoding your knowledge about how you write C code is not a bad way to go for your compiler.
I'm just
I don't
surprised.
remember.
I'm just surprised
don't-
Alan hasn't had more questions for Levo on the memory stuff because this is like
Oh,
Alan's.
well,
This is
no,
Alan's
I
favorite
mean-
topic.
I mean, like
Is
I
it-
know how my memory management works. You know, I have this process.
Okay, I got
but-
a question for you. But first is I don't know when everyone joined, but did you all catch it join before when I explained the mutable and outs function modifiers?
I think,
Like
I think everyone
call
except
site-
Aaron saw that. Yeah.
okay.
Yeah, my internet's been cranky today.
Okay, so when you call a function, if a function parameter is mutable, you have to say mutable at both the call site and the function signature. And if it's out, you also have to say that in both places. So when you were saying that Rust encodes says like I own the pointer, the function parameter has that in the function signature. So that's actually in the compiler, like right now. So that's part of how I do it. Alan, I was just curious, how does your memory management work, and is it completely different from mine?
Oh, well, I mean, like, okay, I'll be honest. Like, I mean, your memory management sounds like Lee's memory management, which is like, oh, I implemented something and I don't know if it works. And like some guy
Oh, I
tested
know mine works, but go on.
and it was like, oh, I managed to get all these terrible memory bugs. And he's like, whoop-de-doo, you know? And like, I don't know. I mean, to me, it sounds very similar. It
Yours is
probably-
more strict, or how does
So, like-
yours work?
Okay, so the way mine works is like you basically turn the program into like this flow transition chart, and then like you it's like a global analysis that analyzes each state of the program and figures out like if a memory allocation could be used from that point in the program. And then
So
like
how does your graph work across functions?
well, so that's the problem is it's a global analysis. So like you literally have to have the entire program. And then like I'm working at a level where the notion of like a function doesn't actually exist. um, like the whole
It sounds
stack
like it's
of
hard
this-
mode, like memory management hard mode, because that sounds
And
very
so-
difficult to do.
Yeah, and so the hard part is like, I mean, it's not like impossible to implement. It's just that it's very hard to implement efficiently. So that's kind of where I am with my memory management. Is
See, I find that
have-
putting boundaries in code makes it more simple, and that's why the functions, function signatures are a boundary, because I don't
Right.
have to look at the body, and
Because
it
if you're
just
coming
makes
from
my compile
assembly,
fast.
if you're coming from assembly, right, you have to create boundaries. Like, okay, who gets to hammer the registers, the caller or the callee? Like, who has to save them? Who has to restore them? Who has, you have to make all those choices. And if you have two people on the project, they have to agree. Because, by the
Yeah.
way, I've never worked on an assembly
Levo-
project with two people. Never, because it's impossible. Like,
Yeah, Levo, do you require your function to return type to be annotated explicitly, or it's not a requirement?
Yes, if you're returning something that belongs to the caller, it like so one of the things I try to do is try to reduce the line noise as much as possible. So by default, everything's like constant. Like when you're passing it into, a lot of things are constant if it's possible. Like the function parameters, and when you assign a value, it just assume it's just like most of the variables I find. You assign it once, use it once, maybe twice, and like that's it. So in those cases, it's kind of a no-brainer to have them default as constants. So when you want to like return like something that belongs to the caller, you have to say so. But if it's super obvious, or if it fits on the stack, the compiler will like try to like not make you be explicit if you don't want to
So
be.
a function, this sounds like a pure function that doesn't capture anything. Do you have something like closures that you refer to something that you don't know how long it will live? Then the function doesn't know when to deallocate itself.
See, I was like thinking about a closure that you don't return, like it would only exist within the function, so you can use. Are you familiar with C Sharp's link?
Mhm.
I'll just type it out for people who don't
SQL.
know.
It's the SQL in the language for working against the other things in the language.
Yeah, so I really like how
Okay,
the
that's like the functional syntax of the
Language integrated query, I
Yeah.
think is what it stands for.
I work with it. Yeah, I know it.
Yeah, so I really like how
Awesome.
they let you say map this to that, and
Okay.
like I like how they write that, and that uses a predicate. So I was thinking like maybe I can have like maybe not a closure, but something for that. But I don't plan to have a closure as like what people call closures. Like that's too much work, and I don't think I can guarantee like.
But for a
speed.
collection, if you have let's say you don't have list, you just stick with arrays, you have a map on the array, what the array should do, should mutate elements in place, should give you a new collection, should give you a slice of something. And when you call it, that will transform elements on demand when you call next, for example.
Yeah, I haven't gone to that part yet, but I have implemented mutable slices where you can't grow it, but you can mutate all the data within.
Right.
So I was like thinking the mutable slices are going to be like how you modify like if it's not a map, and you have to modify data, it's probably going
But
to be a
then
mutable slice.
Then comes the problem if you have a multiple reference to this array and and you mutate some elements underneath and you rely on it earlier in the code to not be the same.
Well, you only have one owner.
So you have to track ownership when the array.
Yeah, that's why the function signatures have out and all that.
And what I would say is this is probably a a good time to wrap it, because
Oh yeah.
we're at 2 hours, and the some of these questions should wait for next week. So
So
because I still don't quite obviously I appreciate it's a lot easier to solve the problem when there's only a single owner for everything. But
Yeah.
there still seems to be something about the problem that's inherently dynamic. And I think that's what you're getting at, Theodore, right? Is that you can't just put code in that says free because if it's got a dynamic aspect to it, how do you know for sure that you can free it? So
if you guys DM me specific situations, I can probably give you a good answer. But I do not support doubly linked lists, or even I don't even know if I support linked lists at the moment. But yeah, I was thinking about using a memory
so
pool for linked lists.
wait. How are we going to implement Lisp on top of your language then?
Big
So
fat array.
I would say for this this CCC Levo, this discussion is really on starting point to think for the next Friday.
No, but that's a
Yeah, I'll
really
try to make it
interesting.
next week.
That's a really interesting statement, though, Levo, that you can't support doubly linked lists, and you're not sure that you can support singly linked lists. So that's because that kind of indicates that actually answers a lot of questions I had, kind of right there.
Maybe singly linked lists work. I just haven't tried it, but I mostly put everything in an array.
Yeah, at least with a singly linked list, everything has a clear owner.
But also with a single linked list, I don't think of it as forward. I think it's like it could be forward, it could be backwards, and backwards would probably not work, but forward might.
Another interesting question: do you support threads? But we will leave it for the next.
I plan to. I mentioned the other day to Cameron that I'm managing the FS segment register for threads. So that's a whole different topic. That's really into details. Yeah,
Well,
that's
cool.
definitely next week. Yeah.
Anybody else have anything to add before we jump off?
I would add that it turned out a nice CCC, we started so hastily and shaky.
If you guys DM me the specific situations, maybe I can talk about it next week, but maybe half of them are going to be like, nope, it doesn't support it. But it's also like only 7 months in. So there's a lot of things it should support that it just doesn't at the moment. And I really should fix that else without a brackets, because that 100% should be a bug. Yeah.
No worries.
So, all right.
Thank you.
Well, have a good weekend, everybody.
Thanks, Cameron.
It was pretty interesting. I still have a lot of questions, but I can save them for next week. So maybe on Discord, you and Alan and Tudor can go back and forth.
We will leave it as a cliffhanger.
A cliffhanger.
And you're going to work with Cliff to get this video up with the rest of them?
Yes, I supposedly am recording it, which I've never tried before, so I have no idea if this will work. Have a good weekend, Matt. Have a good weekend, everyone. Talk to you.
Guys.
Talk to you next week. Bye-bye.